Welcome to MyProjectBazaar.com. Now we are going to discuss about the product. The product title is Power Controllability of a 3-base converter with an unbalanced AC source. In the proposed, a new type of DC to 3-base AC converters using modulation techniques for the modified DC to AC inverters. In these techniques used in the grid connected to the 3-base AC. So the DC to 3-base AC conversion, this technique can be reduce the system leakage current in a great deal and can meet the reduce the harmonic with desired standard. In process done in only a diode is added in front of the original topology to block to leakage current loop during the active vectors and open zero vectors. The pulse width modulation (PWM) technique is applied with one leg shoot through zero vectors in order to reduce the leakage current through the conduction path in the duration of changing from and to open zero vectors. Simultaneously, the leakage current caused by other transition can also be reduced due to the fact that magnitude of a common mode voltage is reduced. The zero sequence current control will help to improve the PWM pulse to achieve the switching status. This is our product flow diagram. Input. Our input is DC voltage. This DC voltage it's converted to AC, so we can use the inverter design. In the inverter is DC to AC converters. It changes the direct current in sine wave AC current. The converters contain switches and LC circuits to change the DC to AC conversion, and then we can use a feedback signal also. In the signals it helps to on off the switches for this conversion, and then in our method we can use two inverters and main it produce a maximum 1000 watts power. In the inverters have 6 switches, each 2 pairs of switches produce on base AC, and total 6 switches produce the 3 base AC, and then output load signal also add, and then PWM generators is modulation techniques that conform the width of the pulse, formally the pulse duration based on the modulator signal information. Although these modulation techniques can be used to encode the information for transmission, its main use is to allow the control of the power supplied to electrical device. And then switching control. In the controllers, the zero sequence current controller helps to generate the power as well level compared to the another type controller. The current sequence controller, we control PWM by using PI and PR controller. And finally, performance of analyze AC output, the fast Fourier transform and the power spectrum are powerful tool for analyzing the measuring the single harmonics. In our proposed, the FFT analyze is measure the voltage harmonic. In the third order harmonic is helps to identify the inverter performance. Finally, we design a DC to AC converters for power oscillation and to reduce the overcurrent problem. This work is to analyze the unbalanced AC source. This system is effectively maintain the power controllability ratio compared to existing methodology. Now we discuss about the flow of the model. We have built the model in simulating tool. The diagram of the proposed topology with a detailed base A shock supporter as on the figure. The voltage shock supporter is provided between the BCC and the load. When a voltage shock occurs at the BCC of any of the bases, the corresponding shock supporter injects approximate voltage in the series with the supply voltage to maintain the desired load voltage. They account for base jump compensation. This topology incorporates the merits of the interbase AC to AC topology by having a shock supporter with two choppers and isolation transformation in each bases. The secondary of the isolation transformer are connected such that they add the output voltage of the choppers and inject them, deriving the injected voltage from two voltage source facilities the regularization their desired reference voltage with base shift. In this scheme, compensation of fundamental quantities has been considered. In case of the harmonics, fundamental component are extracted and compensated by this. A pulse width modulation as AC chopper placed between lines A and B with the two bidirectional switches is placed. A bidirectional feature is an insulated gate bipolar transistor is achieved with a diode bridge. The chopper operates in buck mode and the switching signal records to produce the desired output voltage is given the switch SA. The complementary switching pulse T is given to switch SB to provide the continuous load current. A small passive LC filter is added at the output side filters the high frequency component. A filter is also added at the input side to avoid propagation of noise. The filter output voltage from each chopper are then added and injected using isolation transformer. The line voltage VTAB, VTBC and VTCA are fed to the shock supporters. The three line voltages in baser from the constitute three sector are presented. Each shock supporter can be operated over two sectors. The first chopper in a shock supporter is fed with the line voltage which is common in the two sectors. The second chopper is fed with either of the other two lines voltage of sectors depending on the reference voltage. Selector switches S1, S12, S13 and S121 are employed to select suitable line voltage input for second AC chopper. Since the selector switches are operated based on reference voltage which does not during the voltage shocks event, the switches need not to operate at higher frequency. Therefore, each sag supporter contains the four bidirectional switches operated at high frequency and four others at power frequency. The switching logics selections of sector of operation and the switching logic for the proposed topology to compensate voltage shocks and these sections. The second chopper and the selector switches allow each shock supporter to operate over two selectors, and then we discuss about the result performance. The topology compensate shock is corresponding with the simulation in MATLAB. The proposed dynamic voltage restore a DVR topology with the parameters as given the considerable. The compensation capability of the topology is validated by real-time testing with parameters as given. The photo type of the topology used the study has also given that the experiments are conducted at a reduced voltage scale of the 50 volt. The choppers in the shock supporters are constructed using switching and power diodes and operated at a frequency of 5 kHz. The selector switches S1, S1 bar, S2, S2 bar are realized using single pole double through switches. The filters components remove the high frequency component in the output. The filter output of the chopper is injected using based transformer to minimize the losses. And the last one, AC to AC converter based voltage shock supporter fed with the line voltage has been proposed to compensate voltage shock with base jump. The operation and switching logic of this topology are explained in detail. The capability of the topology is tested for different type of voltage shock and compared with the other topologies. This topology has been advantages of elimination storage devices and providing increased range of the compensation. The efficiency of the proposed topology is validated through simulation and experimental studies. Thank you.